Hello students, in today's lecture I will discuss about raster scan and random scan systems. Raster scan systems are based on television technology. In a raster scan system, the electron beam is swept across the screen one row at a time from top to bottom. As the electron beam moves across each row, the beam intensity is turned on and off to create a pattern of illuminated spots. So here is the diagram of raster scan system, and you can see that the electron beam is moving from left to right. That means the movement is along the scan line. These lines are called as scan lines, and the electron beam is moving across the scan line, and the intensity of electron beam can be off or on, and it depends on the picture of the image. So whatever the portion of the picture is falling on the screen, at that portion the intensity of electron beam is kept on, and the portion where there is no image or no object, at that time the intensity of the electron beam is off. Now in raster scan system we are having one memory that is called as frame buffer or refresh buffer. Picture definition is stored in a memory area called as refresh buffer or frame buffer. So whatever the picture we have to draw, the information of the picture, we have to keep the information in a memory area, and the memory area is called as frame buffer or refresh buffer. Now stored intensity values are then retrieved from the refresh buffer and painted on the screen one row at a time. So here you can see that this electron gun is connected with the frame buffer, and whatever the definition of the picture is stored in the frame buffer, based on that definition the intensity could be turned on or off, and finally we could able to get the image on the raster screen. Now each screen point is referred to as a pixel. So whatever the points that we are plotting, they are referred as pixel. Home television sets and printers are examples. Now for a bi-level system or black and white system, for these systems what is happening, we are keeping only one bit corresponding to each pixel, and if the value of bit is 1, then in that case we turn the electron beam on, and if the value of any pixel is 0 in the frame buffer, in that case we will turn off the intensity of electron beam. But in case of high quality systems, for example if you want to produce a colored image of any object, in that case we are keeping many bits corresponding to each pixel. Additional bits are needed when color and intensity variations can be displayed. Up to 24 bits per pixel are included in high quality systems, which can require several megabytes of storage for the frame buffer, depending on the resolution of the system. Now it depends on the quality of the picture. If you want to keep a high quality image, then obviously you have to keep many bits corresponding to each pixel, and in that case certainly you will require huge amount of memory. For example, a system with 24 bits per pixel and a screen resolution of 1024 cross 1024 requires 3 megabytes of storage for the frame buffer. So you can see that if you are increasing the number of bits per pixel, then certainly you will require huge amount of memory. Now as we have already seen in case of cathode ray tube, the screen is having the phosphorus, and the phosphorus is having persistence. And if we are using a low persistence phosphorus, then certainly we have to refresh the screen so that we could able to maintain the picture on the CRT screen. Refreshing on raster scan display is carried out at the rate of 60 to 80 Hz. That means in raster scan system we have to refresh the CRT screen 60 to 80 times per second. At the end of each scan line, the electron beam returns to the left side of the screen to begin displaying the next scan line. So you can see that in a raster scan system, the electron beam is moving across the scan line, and after completing one scan line, it is moving towards the next scan line. So this we could call it as a horizontal retrace. The return to the left of the screen after refreshing each scan line is called the horizontal retrace of the electron beam. And similarly, we could have a vertical retrace. At the end of each frame, that means at the end of each refresh cycle, the electron beam returns to the top left corner of the screen to begin the next frame, and this we called as vertical retrace. Now the next system we could have, it is a random scan system, and the functioning of random scan system is different in comparison to raster scan system, and these systems are also called as vector displays. Now in random scan systems, the electron beam is directed only to the parts of the screen where a picture is to be drawn. So here the movement of electron beam depends on the image of the object, and normally through these systems we are drawing the objects which are having the structure like line. Random scan monitors draw a picture one line at a time, and for this reason are also referred as vector displays. So you can see in the figure the electron beam is started at this position, and initially it has plotted this line, and after that it is plotting this line, and finally it is plotting this line. So you can see in the figure we are having a triangle, and we know that triangle is a kind of object which consists of three lines. So the movement of electron beam in this case will be, it is at this position, so that it could able to plot the base of the triangle. Then after that it is plotting this side of the triangle, and finally it is plotting this side of the triangle. A pen plotter is an example of such a system. Refresh rate on a random scan system depends on the number of lines to be displayed, because these systems are called as vector displays, and mainly these systems are designed for drawing lines. So the refresh rate, it depends on how many lines we are displaying on the screen. Now in this case the refresh rate could be 30 to 60 times per second. Now here also we are storing the picture definitions in the frame buffer. Picture definition is now stored as a set of line drawing commands in an area of memory referred to as the refresh display file. To display a specified picture, the system cycles through the set of commands in the display file, drawing each component line in turn. In high quality vector systems, they are capable of handling approximately 100,000 short lines at these refresh rates. Random scan systems are designed for line drawing applications and cannot display realistic shaded scenes. So if you want to produce animated image, in that case you have to use the raster scan systems. And normally random scan systems are used in the architecture and manufacturing processes. Now since Picture definition is stored as a set of line drawing instructions and not as a set of intensity values for all screen points. Vector displays generally have higher resolution than raster systems. So these systems are having high resolution in comparison to raster scan systems. And we know that one of the drawback of using the raster scan system is that in raster scan systems we are having the jagged lines, or we can say that in raster scan systems we are having aliasing. So vector displays produce smooth line drawings because the CRT beam directly follows the line path. A raster system, in contrast, produces jagged lines that are plotted as discrete point sets. And this we have already seen in the last lecture of CRT. What is aliasing or what are jagged lines? Now, colored CRT monitor. In colored CRT monitor, we are having three electron gun, that is blue, green and red. A CRT monitor displays color pictures by using a combination of phosphorus that emit different colored light. By combining the emitted light from the different phosphorus, a range of colors can be generated. Color CRTs are designed as RGB monitors, also called full color system or true color system. Now in this we are using one technique that is called as shadow mask, and in this we are having three electron gun, blue, green and red, and here we are having one triangle which is consisting of three dots, red, green and blue. And the functioning of this shadow mask is that the electron gun which is emitting red light must fall on the red spot, and the electron gun which is emitting blue light must fall on the blue, and the electron gun which is emitting green light must fall on the green dot of the triangle which is at the CRT screen. So this is the functioning of the shadow mask. Now in this we use a shadow mask method with intensity from each electron gun, red, green and blue, to produce any color directly on the screen without pre-processing. So in this way we can produce a colored image on the CRT screen. Thank you.